Example 13, the question, you look at the index first. One is power x, one is double of it, one is power 2x. So by observation, the index is double. Again, later we expect to see quadratic equation. First step, as usual, I'm going to split up the terms if I can. So my first item, I'll break it up into 3 power 2x times 3 power 1 plus 27. The last item, there's no way I can split, leave it alone. Now, once you have split, you should see whether you have something to simplify. Otherwise, it's time to do replacement. So it is time to do your replacement right now. Then you should be able to do the algebra from a lower secondary point of view. Now, you're going to highlight the items that I will want to replace. When you replace, you always have to replace the base index, not to replace number. Replace base index. That means you shall be able to see x at the power position, base index. Because sometimes I see students, they will replace number. No point replacing number. Is to replace the most difficult part of the question that you don't want to see. So you should temporarily replace the item so that you can do things from a lower secondary point of view. Now, so this is 3 power x, right? I'm going to let k be 3 power x. So what happened to this 3 power 2x? There is this 3 power x and there's this 3 power 2x. The reason why I let this be k is because this has a smaller index. It's easier to deal with the algebra later on. So x is smaller than 2x. The item with the smaller index, the whole thing, let it be k first. Now what happens if you square both sides? What happens when you square both sides? You will see k squared on the left hand side. I do slowly. When I square both sides, it becomes this. And 2 times x, you actually get 2x. Which means to say that if 3 power x is k, then 3 power 2x must be k squared. That was the reason why I was saying that I expect quadratic. Because at the back of my mind, I know that if this is k, this shall be k squared upon replacement. Okay, so now I have settled the replacement. So one is k, one is k squared. So let me do the substitution right now. So from here, let me do the replacement. This yellow color portion become k squared, right? So k squared times 3. K squared times 3 is 3k squared plus 27 equals to 18k. I can see everybody is divisible by 3. I shall divide by 3, make a number smaller. As long as the 18k, right? I mean, when you divide by 3, you get 6k, right? So you're going to shift everything over to one side and start to do your sec 2 factorization. So this whole thing is completely replaced. Completely replaced. What you see now is a lower secondary quadratic. It's easy to solve. So let's solve this. This one, when I memorize 169 when I factorize it, is this. Otherwise, you can press your calculator or do manual. So I solve this. K equals to 3. Now k, remember, k is a temporary replacement. Temporary replacement. You want to find the exact variable called x, you have to remember that step 3, you have to replace back. Replace back. So remember, k is not my intended variable. Actually, k was 3 power x. If you remember, we have this mentioned earlier on. Okay, so you replace k by 3 power x. So this step becomes 2 terms, right? 2 terms question, you can just equate the power. So power equal power solved.